To do this example, you need to understand what end behavior is. Quick recap. We know that if you have a polynomial function f of x equals x to the power of an even number plus etc., then either I am going to have a polynomial that is facing up, or I will have a polynomial that's facing down. Okay, it all depends on the coefficient of this number. If this is positive, you'll be facing up. If this is a negative number here, then it'll be facing down. Okay, now at the same time, if I have a polynomial f of x equals, again, x to the power of an odd number, then I will have a polynomial where the end behavior goes up and falls down, or the other way around, it will rise up on the left and fall to the right. Again, it depends on the sign on your leading term. Okay, again, review this section to understand it properly. Okay, so the question here is asking, determine the end behavior of the polynomial p of x equals negative 5x to the 6th minus 2x to the 4th plus 3x squared minus 9. So here, the end behavior is decided by this single term. Like the behavior of the graph, or the graph will look depending on what this first term is, or the leading term is. So since I have a negative 5x to the 6th, my graph has to look like 6 is an even number, so the degree is even. So which means my graph has to look something like that. Should be facing down. Okay, we'll check this in your calculator. Y equals, let me clear this, negative 5x to the power of 6 minus 2x to the power of 4. Oops, I think I did something. Negative 5x to the power of 6. I have to hit that arrow here. Minus 2x to the power of 4 plus 3x squared minus 9. Okay, let me keep my viewing window negative 10 for y min and y max 2. Okay, see, I see the graph all the way down here. So let me change my window to window. I'll increase my, like, maybe that to 20. Let's see how it goes. Okay. Okay, so you see here the graph is going down, and that's what I meant by the end behavior. So how do I answer this question? Like, so I can say that since or because the given polynomial has even degree and a negative coefficient. Coefficient is the number attached to the variable term. It will have the following end behavior. So what it means is, when x is going to the positive infinity side, y is going to negative infinity. And when x is going to negative infinity, y is going to negative infinity too. So if I go x positive direction, my y is going down. If I go in x negative direction, y is going down. So this would be a good way to answer this question.